Hello everyone. So in this video we are going to discuss about the basics of NMR spectroscopy. So NMR is a stand for nuclear magnetic resonance. First we are going to discuss about the importance of NMR, or we can say where we can use this NMR technique. Generally NMR is a you can say analytical technique which is used for the analysis of various medicinal compounds, various chemical substances to study their structure and their chemical composition. Okay, so it is used in different industry. For example, if we want to study the structure of protein in biology lab, we can use NMR. We can use NMR to study its dimerization state. Okay, then we can use this technique to determine the molecular structure of any chemical substances, like for example paracetamol have a benzene ring. Okay, so if we do not know the structure of any chemical compound, we use different technique to determine their structure, to determine how many carbon atoms are there, how many hydrogen atoms are there, how many hetero atoms are there. So this technique combinedly used to study their structure. Okay, so in medicinal industry, you can say MRI, magnetic resonance imaging, work on the principle of NMR. Okay, so this NMR technique is also used in MRI. Now come to the type of NMR. Basically, there are different type of NMR, but most commonly HNMR and C13 NMR are used. In HNMR, compound is analyzed on the basis of hydrogen atom. Okay, so on the basis of how many hydrogen atoms are present in the compound, this HNMR technique is used. And in C13 NMR, the compound is analyzed on the basis of carbon atom present in the compound. Now come to the instrumentation of NMR. The most important component of NMR is magnet. Okay, they produce a very strong magnetic field. Okay, large magnets are used to produce a strong magnetic field. Okay, and second one is sample holder. Sample can be liquid or can be solid in NMR technique. Now come to the radio frequency generator. Radio frequency generator is used to produce radio waves which fall on the sample. Okay, the radio frequency waves generated through the generator, and this wave pass through the sample. Present in the sample, absorb this radio waves. Okay, and go to the higher energy state. What happen when radio frequency generator produce radio waves? These waves have energy, and this energy is absorbed by the hydrogen atom present in the compound, and this by absorbing this radio waves, this hydrogen atom go from lower energy state to higher energy state. They shift, and in higher energy state they become unstable. So to make them stable, they release energy and come back to the lower energy state. Okay, so the energy released by the atom is detected by the detector. Okay, while coming from higher energy state to lower energy state, atom release some energy. Okay, and this energy is detected by the detector, and on the basis of that, NMR graph is produced, or you can say NMR spectrum is produced. NMR spectrum is somewhat like that. We obtain a splitted lines, or peaks are there in the spectra. This NMR spectrum help us to identify the possible structure of the nucleus. Okay, with the help of this NMR spectrum, we can identify the structure of molecule. Now, the sample to perform NMR, sample must contain NMR active atom. Okay, so if you want to analyze any compound or any sample, it should have any NMR active atoms in it to perform their NMR analysis. Now, what are NMR active atom? Let's see atoms. So generally, we know we have atom in a compound, and atom have nucleus, and in nucleus neutrons and protons are present, and around the nucleus there is electrons are present. Okay, so positively charged protons are there, neutrons are there, and nucleus is surrounded by electronic clouds. Okay, so what happened? Nucleus have protons and neutrons. This proton and neutrons, under the influence of radio frequency wave, they just rotate on their own axis, spin around their own axis. जैसे like earth is rotating around its axis, on axis. Likewise, neutron and protons are also rotating around their own axis. In NMR, we talk just about nucleus, and nucleus have neutron and protons. Proton and neutron rotated around their own axis. So proton and neutron show spin around their axis. Okay, so they show spin around their axis, and due to which a spin is of neutron and protons, there is a wall spin is there in nucleus. Nucleus also show spin. Okay, inside the nucleus neutron and proton is showing spin, and due to their combined spinning, whole nucleus is also spinning around its own axis. Okay, so the atom which have even number of proton and neutrons, like if atom have two proton and two neutron, four proton and four neutrons, so the nucleus if have a even number of neutron and protons, their spin get pair, they form a pair, and due to which there will be no spin in the nucleus, because if they pair themselves there is no spin, the overall effect get nullified. Okay, and in this case nucleus will show zero spin. Okay, so if there is even number of proton or neutron in the nucleus, the nuclear spin is equal to 0, and that atom are NMR inactive atoms. These atoms that have 0 nuclear spin, that atoms are NMR inactive atoms, or you can say NMR inactive nucleus. So for the NMR technique, NMR active atom must be there in the sample. Now come to the second case, if odd number of either proton or neutron are present in the sample. If proton or neutron, any of the proton or neutron are present in odd number, like 3, like 5, like 7. Okay, so overall spin of the nucleus is non-zero. Okay, so spin of nucleus have some value, but not 0, is equal to non-zero, and that compound or that atom is known as NMR active atom. What is NMR active atom? The atoms which have nuclear spin is equal to non-zero. For example, oxygen 16, it is NMR inactive because 16 neutron and protons are present in it. Okay, and proton are present in even number, neutrons are also present in even number. So we already know that if a proton and neutron are present in even number, then overall spin of the nucleus is 0, so oxygen become NMR inactive. Now come to the second example, that is hydrogen, H2, which have odd number of neutron and proton. So it is NMR active atom, and C13 also have even proton and have odd neutron. So it is also NMR active compound, and nitrogen 15 is also NMR active atom because it have odd number of proton and even number of neutrons.